Welcome to the packet on term combining. As we prepare for algebra, we're going to need term combining skills. This will help us simplify expressions and solve equations. We're going to use the rules for adding integers, or I like to think of it as combining integers. We're going to use those rules to help us term combine. Let's take a look and review the rules. If you currently don't have a packet, please use a notebook and take down this information in your notebook. Let's begin. Please construct this T-chart on your cover page. On the first column, you should label it same signs. On the second, different signs. This is the T-chart we used for adding integers or combining integers. Let's take a look at a simple problem for each. Remember, when you have the same signs, we actually add up the units. But when you have different signs being combined, you actually subtract the units. Let's take a look at a simple problem. If we have -5 plus a -4, please record this in your notes. We know we add up a loss of 5 and a loss of 4. What do we get? A -9. Well, we're going to expand our understanding of combining two negatives and throw in some different kinds of terms, such as this. -5x plus or combined with -4x. Well, if you combine those terms together, you get a -9x. And we can even have terms that look like this. -5x squared plus -4x squared. We get, as we combine those like terms together, -9x squared. Please record those notes on your paper. Pause the video if you need a little extra time. Let's take a look at the other side of the table. If I have -10 plus a +4, this is a loss of 10 but a gain of 4. We actually find the difference here. When you find the difference, you get an answer of -6. Well, we can take what we know about this and expand it to combining other terms. So if I have -10x plus a +4x, I combine it just like the previous problem. A -10 and a +4 give me -6x. And we can do this with an x squared term. -10x squared plus 4x squared. Once again, a loss of 10, but a gain of 4 leaves me with a -6x squared. It's important to master these rules. Why? Because we use it in so many different parts of algebra. Let's turn the page and let's try some combining problems. Here we go. Please turn to page 2. On page 2, we are going to be combining like terms. We're going to be using those addition rules for integers to help us simplify expressions that we've been given. But let's talk about what a term is. A term is a piece or a part of an expression. This particular term is called the variable term. It's made up of two parts. The 4 is called the coefficient, and the x is the variable part. This is the variable term. And then there's the constant term. The -10 or the loss of 10 is called the constant term. And constants can only be combined with other constants. As we go through this, we're going to box in our x terms and circle our constants. Make sure when you circle or box your terms, you include the sign associated with that term. X terms can only go with other x terms, and constants can only go with other constants. Keep in mind, a variable doesn't always have to be an x. It can be like this, 4b minus 7, or 4w plus 6. So the letter is not important, but x is very common, and we'll start off with using the variable x. Another important piece of information worth mentioning is that the variable term doesn't always appear first. If we take our top expression, we could rewrite it as -7, the sign travels with the 7, and we know that this 4b is a positive or a gain of 4, so we write plus 4b. That expression can be written that way. However, we tend to put the variable term first. Let's take a look at some simple vocabulary, and then we'll term combine. We'll be working with polynomials. Poly means many, and nomial stands for term. So many terms. Think of it almost like the parts or pieces of a choo-choo train linked together. An example of a polynomial might be something like this. Please jot down this example of a polynomial. 4x to the third power minus 5x squared plus 6x take away or minus 7. Here we have 4 distinct terms. This expression is in simplest form. No term combining can occur. This is an example of a polynomial. But the type of polynomials we'll work with are going to be a bit simpler. There's a monomial, a binomial, and a trinomial. Monomial means one term and one term only. A monomial might be -7x squared. And that's it. One simple term. A binomial has 2 terms, such as -6x plus 4. And lastly, a trinomial will have 3 terms. Please take down these notes. -4x squared minus 3x plus 1. That's an example of a trinomial. We'll mostly be working with binomials and monomials. Let's take a look at a simple term combining exercise. At the bottom of the page, you see 4 problems or 4 expressions. It's our job to simplify each expression. How are we going to do that? by term combining. Remember, our x terms will get a box. So box in positive 5x and box in a gain of 2 x's. Make sure you grab the sign in front of the 2. The 5, of course, we know is positive, but if you'd like to, you can add a positive symbol. Circle a gain of 6, which is a constant, and a gain of 3, which is a constant. Bring together your x terms. A gain and a gain give you 7x. And then bring together your constants. A gain of 6 and a gain of 3 give you a gain of 9. 7x plus 9. No need to put the positive symbol in front of the 7. Let's move on to the next. Here we go. Box in the 4x. Box in the loss of 2 x's. For our constant, circle the gain of 2 and circle the loss of 5. Now let's bring like terms together. 4x, but a loss of 2 is 2x. And then a gain of 2, but a loss of 5. For our constant term, well, that's a loss of 3, or minus 3. 2x minus 3. It's a binomial, and that's all we can do when it comes to simplifying this expression. Let's go on to the next two together, and then you'll work on the next page on your own. Let's box in our x terms, and we'll box it in over here as well. Make sure you grab the signs in front of each term, and let's circle our constants. Once again, making sure to grab the sign in front of the number. Please pause your video and try problems 3 and 4 on your own. When you're ready, turn the video back on and take a look at the answers. For number 3, you should have got negative 3x plus 1. And for number 4, negative 6x minus 7. Turn the page and let's look at page 3 of your packet. Let's try a couple of problems together, and then you can work on your own and check your own work. If you're working in a notebook, copy down the problems and show your work in the notebook. I'd like to start at problem number 6. Let's box in the x term, making sure to grab the sign. There seems to be only one x term. And let's circle the constants. A loss of 5 and a gain of 6. Now I could combine my constants together first. I get a positive 1. And for my x term, we bring down the gain of 4x. X term first. We could rewrite this as 4x plus 1. Either answer is correct, but that's the best way to do it in standard form. Let's take a look at another problem. Let's take a look at number 11. Box in your x terms, a loss of 3x, a gain of 6x, and a loss of 10x, and circle your constant, a loss of 7. We're going to combine like terms. A loss of 3, a gain of 6, which brings us to a positive 3, and a loss of 10. We get negative 7x. And our constant? Well, there's nobody to combine the constant with, so we get a negative 7. One more. Take a look at the very last problem on the page. A loss of 5x, a loss of 6x, and a loss of 10x. As we combine a loss of 5, a loss of 6, and a loss of 10, we get negative 21x. This is a monomial, only one term. There are no constant terms. So, this is what we would call a monomial. Over here, this, of course, is a binomial. Now, pause the video, term combine. Make sure you box in your x terms and circle your constant terms. Make sure you grab the sign inside the box or the circle, the sign that sits in front of the value. Pause the video, and then when you're ready, turn the video back on to check it. Check your work with the answer key. Give yourself a C if it's correct. This concludes the video on term combining.